In this class, we will discuss measures of variation. The center of a dataset can be measured by mean, median, or mode. However, measures of center do not capture all features in a dataset. Two datasets with the same mean, median, or mode can still be quite different. Look at the picture. It shows two basketball teams. Each team has 5 players. Their heights are listed. We can see that both teams have the same mean, median, and mode. However, the players in Team 1 have similar height to each other. The players in Team 2 show more variations in height. It indicates that we need a measure of variation for a dataset. Measures of variation or measures of spread quantify the amount of variation or spread in a dataset. There are two commonly used measures, including range and standard deviation. Both of them are applicable only for quantitative data. The range is the difference between the maximum and the minimum. The maximum is the largest number, and the minimum is the smallest number. For Team 1, the maximum is 78, and the minimum is 72, so the range is 6. For Team 2, the maximum is 84, and the minimum is 67, so the range is 17. The range of Team 2 is much larger than the range of Team 1. So the heights of players in Team 2 spread wider than the heights of players in Team 1. The sample standard deviation is the most common measure of variation. It measures how far the observations are from the mean on average. Usually, we will first define variance. Assume that the data are x1, x2 up to xn. The formula for calculating the variance is displayed on the slide. We use S squared to denote the variance. First, need to calculate the difference between each xi and x bar, while x bar is the sample mean. Then calculate the squared sum, and last, divide the sum by n-1. Notice that the variance must be a non-negative number. The standard deviation is the square root of the variance. After calculating the variance, we take square root to get the standard deviation. We use S to denote the standard deviation. The standard deviation is always non-negative. This slide lists more detailed steps to calculate variance and standard deviation. Step 1. Calculate the sample mean x bar. Step 2. Compute the deviation of xi from x bar for each observation. Step 3. Calculate the sum of squared deviations. Step 4. Compute the sample variance by divide the sum of squared deviation by n-1. Step 5. Compute the standard deviation by taking square root. Let's look at an example. We want to calculate the variance and standard deviation of 5 players in Team 1. We have already known that the sample mean is x bar equals 75. The table shows the steps of detailed calculation. We first write out all numbers in the first column. In the second column, each number in the first column is subtracted by the sample mean 75. Hence, the second column is the deviation. In the third column, we calculate the squared deviation and then add them together. It gives us 24. The sample variance is 24 divided by 5 minus 1. Notice that 5 is the sample size. Therefore, the variance is 6. The sample standard deviation is square root 6, or approximately 2.4 inches. Similarly, we can calculate the standard deviation of heights of players in Team 2. It is square root 39, or approximately 6.2 inches. The heights of players in Team 2 have a larger variation than the heights of players in Team 1. The standard deviation is also larger. Generally, the more variation there is in a dataset, the larger is its standard deviation and variance. In this table, we list some Excel functions to calculate quantities related to variation. The function var is used to calculate variance. The stdev is used to calculate standard deviation. The function min is used to calculate minimum, and max is used to calculate the maximum. There is no function to directly compute the range of a dataset. We need to calculate minimum and maximum separately, and then calculate their difference to get the range.